Now, these are the basic principles in geometry. One is the rule of perpendicular. In solving areas, volume, the two quantities that you will multiply must always be perpendicular. The rule of three, for an unknown side or angle of a triangle to be solvable, the known must be 3. It must be 3 sides, 2 sides, 1 angle, or 1 side, 2 angles. Now, the divide and rule concept, pagka binigyan ka ng malaking figure, syempre, binigyan ka ng malaking pizza, hindi mo kaya subo lahat. You have to divide it, eat it, one piece at a time. So, eventually, ubos ang malaking pizza. Okay? Now, yung pang-apat, if you can divide it into equal figures, that is the rule of symmetry. If you were able to divide it into symmetrical figure, then all you need to do is multiply it by the number of symmetrical parts. Okay? Now, pagka hindi tayo binigyan ng specification as to the kind of polygon mentioned in the problem, it is automatically understood that we are talking of regular polygons. Regular polygons are polygons that are both equilateral and equiangular. Equal sides, equal angles. And thus, it can be inscribed in a circle. Now, let us try to have a problem here. Find the area of a regular nonagon 9-sided polygon, whose apothem is 10. What is an apothem? If you will draw a circle inside the polygon, the radius of that is the apothem. So, ibig sabihin, kung nag-drawing ako ng circle dito, and I draw the radius, ang radius na circle na yan, eto, perpendicular to the side. So, yung apothem daw, this one is 10. Hinahanap sa atin yung area ng nonagon. Now, the nonagon can be subdivided into 9 equal triangles. This one. Right? And this triangle is isosceles. By the rule of symmetry, I can still divide this into 2 equal parts. Ito. Itong right triangle na to. Correct? Into how many equal right triangles can you subdivide the whole nonagon? Each isosceles triangle is 2 equilateral, symmetrical equilateral triangles. So, times 9, 18 right triangles. So, therefore, for this, yung area niyang right triangle na yan must be solved. Times 18, we have the area. So, ulitin ko, the area of the nonagon must be equal to 18 times area of that right triangle. Hindi mo kailangang i-memorize. Kasi ang dami mong variation nito. Pero ang principle laging divide and rule lang. So, it will boil down to solution of triangles. Most of the times, solution of right triangle. So, therefore, for this triangle, I need to find the area. Meron na akong base. Ang kailangan ko na lang ito. Tawagin ko to na x. So, the area of this right triangle is 1/2 of x by height. Tama? And the height is 10. So, isa na lang ang kailangan ko. Kailangan ko ng x. In this triangle, to solve x, rule of 3. I need 3 elements. I know one side. I know one angle, 90. I need one more. One side, one angle, one more. This angle can be solved. This entire thing is 360, right? And we divide it into how many equal right triangles? 18. So, therefore, this angle must be 360 divided by 18. And this is 20 degrees. So, this angle is 20 degrees. Take note of this triangle. If I will take here the tangent of 20, this is equal to opposite x over 10, the adjacent. And this will give me the value of x, and x is 3.64. So, substituting this to this area of nonagon, the area of the nonagon is going to be equal to 18 times area of the right triangle, 1/2 of the base. So the base is x, and the height is the apothem 10. So just substitute this value of x here, and we will get the area of the nonagon. And the area of the nonagon is going to be 327.6 square units. Huwag kayong ma-overwhelm sa malaki. Just divide and roll. Mahirap mag-review. Pero kung ang review, gagawin yung one piece, manageable piece at a time. Few lessons every day, one exam every day, gawin yung discipline. Huwag kayong mag-marathon exam. Gawin yung discipline. One exam every day. Piliin nyo lang yung oras nyo. This is the beauty nitong online. Pwede mong i-adjust ang schedule mo. Kailangan mo lang ayusin, i-manage ang schedule mo. One piece at a time, you'll be able to rule the board exam. Ang kailangan mo lang, consistency. Okay? What is a peripheral or inscribed angle theorem? It is this one. If I have here this circle and this is the center, the angle subtended by this arc is the central angle theta. If this is theta, 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 this is also theta. Of course, in terms of angular measure, it is theta. In terms of linear measure, it is s, which I presented to you a while ago as equal to theta times r. Now, what is a peripheral angle? This is called the central angle because it is the center of the circle. A peripheral or an inscribed angle is an angle whose vertex is along the periphery of the circle. Not inside, not outside, but on the periphery of the circle. For example, let me choose this point as the vertex of an arc opposite this. So, let us say that this is this angle. The angle subtended by this arc about the central point or the center is the central angle theta, which is numerically equal to this in terms of degrees or radians. Now, if I call this angle as gamma, gamma is called a peripheral angle because its vertex is on the periphery of the circle. Now, take note that gamma is theta over 2. This is the peripheral angle theorem. Kung ito ay theta over 2, this one, another peripheral angle opposite this arc, this is also theta over 2, which is gamma. This angle is also gamma. This angle is also gamma. Lahat sila na opposite nito, ang vertex nasa periphery is gamma. And they are all theta over 2. Now, it is simple to prove that. Ganito. Look here. If I begin here with this circle, eto, kung ito ay, tawagin ko tong beta. Kung ito ay beta, let me begin with this diameter. Now, what is the measure of this angle? 180 minus beta, right? 180 minus beta. Consider this triangle. This is radius, this is radius. pareha silang radius. So this angle, this triangle is isosceles. So this angle and this angle are equal. Correct? Tawagin ko to na alpha. Alpha. So alpha plus this must be 180, right? So I have 2 alpha plus 180 minus beta is 180 degrees. Sum of interior angles of a triangle. So therefore, we have here 180 degrees will cancel. So what is your alpha? 2 alpha is equal to beta. Alpha is beta over 2. So this angle is 1/2 of beta. Beta is the central angle. Alpha is your peripheral angle. Peripheral angle is half of the central angle. You might ask me, sir, this one, this and this is not a diameter. Is this proof true even the sides are not diameter like this? Yes. I am using this as the foundation. For example, balikan natin, ha? Let us say that this is your theta. And this is your gamma. Any point, ha? This is your gamma. Now, from here, let me draw a subdividing line passing through the vertex and the center. Ito. So this one is a diameter. Correct? Kung ito tatawagin kong beta, and ito tatawagin kong alpha, do you agree that alpha is 1/2 of beta? Yeah. Because this is a diameter. Ito yan. Beta, alpha. Correct. Now what about if I will call this as beta prime? This one. This is a diameter. What is this equal to? Kung tatawagin ko naman tong alpha prime. This is central angle. This is alpha prime. Then, alpha prime must be half of beta prime, right? So I have here, alpha is half of beta. Alpha prime is half of beta prime. If I'm going to add them, alpha plus alpha prime is gamma. Beta plus beta prime is theta over 2. This is the peripheral angle theorem. When you notice that in the figure or even in the problem, even if the figure is not given, but when you draw it, it yields a figure, one vertex is on the periphery of the circle. Always remember, don't forget the peripheral angle theorem. One commonly frequently encountered application of the peripheral angle is on an inscribed triangle. If I have an inscribed triangle, one side being a diameter. Ito. Yung isang side niya diameter. This need not be at the center of this. Okay? Now, this is a diameter. If this is a diameter, this is half circle, right? Pag meron kang triangle, all vertices are on the periphery of the circle, it is an inscribed triangle. And if one side is a diameter, this is a special triangle. Why? Because kung diameter to, this is a half circle, this must be 180 degrees. Applying peripheral angle theorem, if this is theta, gamma is half theta. If this is 180, a peripheral angle opposite this is this one. This must be 180 over 2. So this must be 90 degrees. So this triangle is a right triangle. So this one is a right triangle. This one is a right triangle. This one is a right triangle. Basta inscribed triangle, one side is a diameter. You follow? Okay. Now let us try to have this problem. In this problem, we are asked here to find the value of this theta of that inscribed triangle. Now there is a given angle here, 45 degrees. As I told you, whenever you have a figure or you came up with a figure, one angle is on the periphery of a circle. Don't forget the peripheral or inscribed angle theorem. Now, if this is 45, opposite 45 is this arc. So if the peripheral angle is half the opposite arc, then the opposite arc must be twice the peripheral. So kung 45 to, how much is this? 90 degrees. Okay? Now theta is a peripheral angle because its vertex is on the periphery of the circle, right? So dito, it is a peripheral angle opposite. This is a radius. Let me project it here. Opposite this arc. Right? Kung ito ay theta, the arc opposite this one measures how much? If this is theta, this must be twice of theta. We want theta, right? So, dito, kung ito ay diameter, then this is a semicircle. If that is a semicircle, how many degrees is that? Correct, 180. So, this must be 90 plus 2 theta is equal to what? 180 degrees. Half circle. Solving theta, it's 180 minus 90. 90 over 2. Theta is 45 degrees. Peripheral angle theorem. The peripheral angle is half the central angle or the opposite arc, or the opposite arc is twice the peripheral angle. A cyclic quadrilateral is a quadrilateral inscribed in a circle. All the vertices are on the periphery of the circle, so all interior angles are peripheral angles. Its area is maximum. Compared to other quadrilaterals with the same sides A, B, C, and D, it is the one with maximum area. That can be proven by maxima, minima, using differential calculus. Look here. If these are the sides A, B, C, and D, like that, a quadrilateral is not like a triangle. For a quadrilateral, there are many areas that can be formed from maximum to minimum to maximum to minimum. The time when its area is maximum is the time when all the vertices will fall on a circle. But we will not prove that as of now because we don't have calculus yet. Now, the second concept is that the opposite angles are supplementary. Sum is 180. This plus this is 180. For example, this is theta. Theta is opposite this arc, right? It is a peripheral angle opposite this arc. Meaning this arc from here to here, eto, hanggang dito, this one, this is 2 theta. If I will call this as beta, Beta is also a peripheral angle opposite this arc. From here to here. Mula dito hanggang dito. So kung ito beta, this one must be twice of beta. 2 theta plus 2 beta is what? 360 degrees. Diba? So 2 theta plus 2 beta is 360 degrees. Divide everything by 2, you'll have theta plus beta is 180 degrees. Kuha niya? So, sum of opposite angles is always 180. The last is the Ptolemy's formula. It was the mathematician, the Greek mathematician whose name is Ptolemy, who formulated this formula. Now, the proof of this is also peripheral angle theorem. Now, according to this theorem, the sum of product of opposite sides A times C plus B times D is equal to the product of the diagonals D1 and D2. Para bang Acevedo, Dedo. Isipin mo si Ptolemy, best friend si Acevedo. Buhay pa ba si Acevedo? Yung nagtayo ng Acevedo Optical. Mga anak na yan ngayon. So, Dedo na yan. Si Acevedo, Dedo. You follow? Okay. In this problem, we have here a quadrilateral whose sides are 3, 4, and 5, and the other side is a diameter of the semicircle. So this one is a semicircle, and this is a semicircular arc. We want here the diameter. Now, if this is a semicircle, if I will complete it, I have here a circle. So I have now a cyclic quadrilateral, right? Tama po. I can apply this concept and this concept or another concept to solve the diameter. Let me call the diameter as D. Now let me apply this concept. If I'm going to divide this quadrilateral into 2 triangles so that my solution will be solution of triangles, divide and rule concept. Now, in this triangle, take note, this is a triangle, one side is a diameter. What is the measure of this angle? As I told you a while ago, this is 90 degrees. It's a right triangle. So kung ito ay theta, to solve the rule of 3 ang kailangan mo. Correct? Tawagin natin tong this is 5. Let me call this subdividing line as x. Para ma-solve mo yung D, you need 3. I have one side, 5. I have one angle, 90. I just need one more. I need to find theta. I need to solve x. Isa lang sa kanilang ma-solve. Tapos na to. Okay? So, paano natin makukuha yung x o yung theta? Look, from this right triangle, I can say that x squared plus 5 squared, applying Pythagorean theorem, is equal to d squared. Let me call this equation 1. I need x to solve d. May dalawa pang given dito na hindi natin nagagamit, 3 and 4. Now, considering this triangle, take note, if this is theta, the sum of opposite angles is 180 of this quadrilateral, right? So, kung ito theta, this angle must be 180 degrees minus theta. Therefore, dito, from this triangle, I know two sides, kulang pa ng isa. Kasi rule of 3, kulang na isa. But I can establish an equation in this triangle. Para, in terms of theta and x then, let me apply cosine law. If I will apply cosine law here, to use this angle, I will begin with the side opposite x. So I have here x squared is equal to the square of the other two sides 3 squared plus 4 squared minus twice their product, 2 times 4 times 3 cosine of the angle opposite of x, that is 180 minus theta. How many unknowns do we have? X, D, theta. 3 unknowns. We need one more equation between X, D, and theta. But look, in this triangle, this is a right triangle. I can define the function of theta, sine, cosine, or tangent, right? Let me simplify this. I have here x squared is 9 plus 16, 25 minus 2 times 4, 8 times 3, 24. This is cosine of difference of two angles. Let me call this A, let me call this B. Parang AB, no? Difference. Pagka cosine, di ba, cos-sin? So, cos sin. And they have the opposite sign. This is minus, this must be plus. Then, ABA. Angle A to, this is 180 degrees. This is 180 degrees. Tapos ito, B, theta. Okay? Now, the cosine of 180 degrees is, from your calculator, this is negative 1. The sine of 180 degrees, this is 0. So, 0 times this, 0. Ang matitira lang, etong part na to. So, simplifying this further, I have x squared is equal to 25 minus 24 times minus cosine theta. So, plus 24 cosine of theta. Let me call this as equation 2. X, theta, and D. 3 equations. I need one more. But take note that cosine theta can be expressed and defined from this right triangle. It's adjacent over hypotenuse. So if this is theta, the cosine of theta is 5 over D, right? I can express this in terms of D. I can also express x from equation 1 in terms of D. Tapos ang kwento, right? So, therefore, simplifying this, we will have here x squared from this equation is d squared minus 25, right? So, I have here d squared minus 25. So, I have d squared minus 25. That's x squared. Is equal to 25 plus 24 cosine theta, which is 5 over D. So this is plus 24 times 5 over D. Okay? So this is one equation in terms of D. You input that in your calculator. The good thing is calculators with shift solve is allowed. Okay? So, kailangan lang marunong kayong gumamit ng calculator. Kahit pa mawala yung shift solve na yan, basta may mode table, kaya yan. Pero, meron naman. Di, bili lang tayo ng calculator na meron. Okay? So, you solve this equation and your calculator will give you 8.056. This is the diameter of your semi-circle. Kuha niya? Yung divide and rule concept, very effective. Basta nakakita ka ng malaki, huwag kang ma-overwhelm. Pira-pirasin mo lang. Unti-untiin mo yan. Diba? Yung board exam, huwag kang ma-overwhelm. Huwag mong kainin ng biglaan. Yung iba, ang ginagawa, di ba, refresher lang. Paano mo kakainin yon? Refresher ka lang pumunta. Di, unti-untiin mo. Halimbawa, yung mga dati nang nagtatrabaho, di, i-1 year mo yung review mo. Tapos, pero pag nakakalahati ka na, dumating yung board exam, take ka ng board exam. Di ba? Ngayong November, take ka na ngayong November. Di ba? So, huwag mong sayangin bawat opportunity. Yung iba, di ba, sa May na daw sila magdetake. Paano kung may board exam ngayon? Ang laking nawawala, no? So, bakit ka magpapahinga kung pwede namang hindi, di ba? Bakit ka magmi-miss kung pwede namang hindi? Bakit mo i-delay kung pwede naman ngayon, di ba? Okay? Hindi naman yung katulad ng nag-aaral ka ng college. Siyempre, talagang pwede kang mag-stop dahil una, malaking binabayad mo. Pangalawa, mag-stop ka. Wala namang talagang mawawala sa'yo. Pag tumuloy ka naman, nag-online, naninibago yung mga schools. Trial and error ba? Okay, saka puro activities. Katulad din ng mga online review ng ibang center, di ba? Activities. Di, bili ka na lang ng libro tapos tingin ka sa libro or mga books, mga review books, di ba? Bili mo lahat ng libro ni Engineer Padilla, di sama mo pati sa ibang review center, di ba? Kung kaya mo. Pero, ako para sa akin, may board exam o wala sa November, hindi ka talo pag nag-review ka. Eto napansin ko, yung mga nagre-review nito para sa May na board exam sana, yung nakaraan, tapos nung nawala yung momentum nila. Pag nagpahinga ka, mawawala ang momentum mo. Okay? Ang pahinga nakakasira ng diskarte. Di ba? Ang nagpapahinga yung pagod. Ba't ka magpapahinga, hindi ka naman pagod? Di ba? May COVID lang. Di ba? So, tuloy ang laban. Laban lang, no? Another situation that you might encounter in the board exam is the tangent circle or the multiple circle problems. Now, the general case is this. If you have 2 or more circles, you begin by defining the center-to-center segment. 100% sure you'll be using the segment, the center-to-center distance, either that is given or required in the problem. Normally, you'll use this in connection with a triangle. Now, the second general case here is if you have a tangent line to a circle, always begin by drawing the radius to the point of tangency. So, if this is the tangent line, the radius here will be perpendicular to that. 100% sure you'll be using this radius segment. And if this is tangent line to this is radius, this is perpendicular to this radius or to the tangent line. So, as you can see here, eto, pagka i-project ko to dito, something like this, para mapakinabangan nyo yung R and yung center to center, kung eto R, this is small r, so it means this is R minus R. Correct? R minus R. And since this is projection nito, no? Parallel to this, it means this is also 90 degrees. This is a right triangle. Kung yung R and R known, and this is known, this can be solved. Whatever is the problem. Okay? Now, dito, if you have 2 circles that are tangent, magkadikit, tangent externally, ito yung point of tangency. The center to center segment is r plus small r. Now, if you have two circles that are tangent internally, this is their point of tangency. This is big R. This is small r. So the center to center segment must be r minus r. So you begin with this. Don't memorize it as a formula. Always remember it by the drawing or by the principle. Okay? Let us take this problem. We're asked here to find the radius of this small circle that is tangent both to this square and to this circle. Now, this is 2 meters by 2 meters square, meaning the diameter of the big circle is 2. The radius must be 1. How shall we find the radius of this small circle? Let us begin with the fundamental. Whenever we are talking of two circles, the first thing to do is to connect their centers. The radius of this is 1, so this is 1, and the radius of this is small r, so this is 1 plus small r. Now, applying the tangent line concept, this line is tangent to both circles. So we connect this to the center of the circle. This is 1. We connect this, the point of tangency, to the center. This is small r. Okay? So that is small r. This one. Okay? Ngayon, so how are we going to use this and this together with this? Simple. Let me construct a triangle where I can use this. So, in here, this is 1, this is small r. So, therefore, this would be what? This is 1 minus small r. Now, using that concept on this side also, this is small r, this is 1. If this is small r, this is 1, then what is this? This is also 1 minus small r. So, considering this right triangle now, this is 1 minus r, this is 1 minus r, this is 1 plus r. Applying Pythagorean theorem, square of this plus square of this is square of this. So, I have here 1 minus r squared plus 1 minus r squared is equal to the hypotenuse, this one, 1 plus small r squared. So this is one equation in terms of r. Input that in your calculator and solve for r. You'll get this to be 0.17 meters. So whenever you're given two or more circles, always begin with the center to center segment. Ulitin ko, 100% sure. You'll be using that center to center segment in your solution in finding for the required, normally in connection with a triangle. We are asked here to find the area between two circles. This time, they are tangent internally. The two circles are in contact here, but this time, the small circle is inside the big circle. This is the point of tangency. Now, the area between them, this one, the area outside the small circle but inside the big circle, is simply the area of the big circle, remove the area between. Parang itlog, no? Parang white ng itlog na nilaga. So, yung area shaded is simply the area of the big circle, that is pi r squared, minus the area of the small circle pi small r squared. If we factor out pi here, this would be r squared minus small r squared. Let me call this as equation 1. To solve the area of the shaded region, we need r, we need small r, or we need at least r squared minus small r squared. Now, according to this problem as per given, the two diameters were cut by the small circle and form segments that are 5, 5, and 9. Because this is symmetrical, I would presume, and it is very logical to conclude that their centers are here. So, the first thing to do is connect their centers. If they are tangent internally, their center to center is what? From the center of the small circle to the point of tangency, this is small r, right? From the center of the big circle, this one, to the point of tangency, this must be big R. So obviously, this is big R, this small r. The center to center is R minus R. So paano natin gagamitin yan? How shall we get two equations between R and R utilizing this segment? Ganito. Let me make use of this 9. This is the center of the big circle. This is from here to here. That's radius. If this is 9, this must be what? R minus 9, right? So, etong segment na to, this one is R minus 9. But this is the center of the small circle. This must be, this is radius, this must be small r. By observation, this plus this is small r. So I have r minus 9 plus r minus small r is small r. We simplify this, r plus r, this is 2r minus r minus small r, 2 small r is equal to, move the negative 9 to the right, this is 9. Divide everything by 2, you'll have r minus small r is 4.5. Let me call this equation I. So I need just one more equation between r and r, and I'll be able to solve r and r and solve the area of shaded that is required. Now, but before I continue, take note, this is r minus r. That is this one. So we learned that this is fixed for that particular problem to be 4.5. Now, there is one more given that we can use in the same way we use 9, and that is 5. From the center of the big circle to any point of the big circle, that is radius. This is r, right? Kung ito ay big R, and this is 5, this must be what? Obviously, that is R minus 5. How are we going to use this in connection with this? Ganito, let's complete the triangle. Remember that this is the center of the small circle. Center to any point on the small circle is small r. So from here to here, this is small r. So considering this right triangle, square of this plus square of this is square of that. So I have here r minus 5 squared plus r minus small r squared is equal to small r squared. So, substituting this to this, and yung r can be replaced by small r plus 4.5, i-substitute dito. So, you have small r plus 4.5, that is your big R from this equation, minus 5 quantity squared, plus r minus r is 4.5, is equal to small r squared. This is one equation in terms of small r. So therefore, if you compute this equation, you'll get r to be 20.5. Knowing small r, I can substitute that to equation I, and I'll be able to solve big R. So your big R minus 20.5 is equal to 4.5. So therefore, our big R is 25 square units. Knowing R and small r, we'll be able to solve the area of the shaded region. So the area, therefore, of the shaded region is going to be equal to pi times big R, 25 squared, minus small r, that is 20.5 squared. You calculate this, and you'll get here 643.24 square units. This is the area between the two circles, which I illustrated by the shaded region. Naintindihan niya? Any question? Wait, basta may question lang kayo, ha? Lagay nyo lang dyan sa my Facebook. I-message nyo lang ako. Ha? Comment lang kayo. Pero kahit wala kayong question, comment kayo dyan, mag-react kayo para sa malaman natin na kung ano yung dating sa inyo. Ha? Okay? Please comment, please like yung page natin. Campaign for it. Okay? Thank you. So, see you. This time, we have two concentric circles. We are asked here to find the area of the annulus. The area of the annulus is the area bounded by two concentric circles. Concentric meaning they have the same center, and having a chord of the big circle tangent to the small circle whose length is 10 units. So, how are we going to solve this? So obviously, the area of the annulus, which is the shaded region, is equal to the area of the big circle, pi big R squared minus pi small r squared, just like the previous problem. So this is pi r squared minus small r squared closed quantity. So let me call this equation 1. So, we need to find r and small r. Two unknowns require two equations. The only given here is this tangent chord. So, merong isang issue or merong isang problem dito sa problem na to. If you encounter this problem for the first time and you try to solve this, you might carelessly think that the problem lacks given. Why? With this figure, that this chord is 10, you can draw a lot of different sizes of circle pairs. For example, let me draw it. Let me just copy this length of chord whose length is 10. This is 10, no? So, from here to here. This is as long as this chord na 10. So, I can draw a lot of circles, different sizes, that can contain this chord 10. So, for example, I have this one. This one is smaller than this one. Or I can draw something bigger, something like this. Or I can draw something even bigger. So, you might think that the problem lacks given to solve big R and small r. Obviously, the radius of these circles are different. But does it mean that we can not really solve the problem? Let us see, no? So, we need R, we need small r. Now, using the concept here of the tangent line, this is tangent to this, the first thing to do is draw the radius from the point of tangency to the center. This is the radius of the small circle. How are we going to use this r in connection with 10 in order to find an equation between r and small r? Ganito. Let me complete the triangle. This is the radius of the big circle. And by symmetry, kung eto 10, this must be 5. So applying Pythagorean theorem to this triangle, we have small r squared plus 5 squared is big R squared. Let me call this equation I. To solve r and small r to find the area of the shaded region, we need two equations. But we have here only one. And as per our discussion here, we cannot specifically solve a value for big R. But that does not mean that the problem is not solvable. Because take note that while R will change, there's a possibility that small r will change correspondingly. Look here. We're going to transpose small r here. You'll get here r squared minus small r squared is 5 squared. That is 25. We might not be able to solve r and small r. Yes, we cannot solve it. But it doesn't mean that we cannot solve the problem because we have r squared minus r squared here, 25, which is exactly just the one that is needed here. So substituting this to equation 1, therefore, the area of the shaded region is equal to pi times r squared minus small r squared, that is 25. Or the area of the shaded region, or of the annulus, is 25 pi square units. Naintindihan? Let me introduce to you Padilla-Sharp principle. If something can legally change in size, most especially in geometry problems, when I say legally change in size, it means without changing the answer. Because if the problem doesn't lack given, if it is correct, then even with the change in the size of the figure that is legally changed, the answer remains the same, then it means you may use any size of the figure. Now, kung ikaw makikipaglaban at ikaw ang mamimili ng kalaban mo, anong kalaban ang pipiliin mo? Malaki o maliit sa'yo? Yung mas maliit, right? Eh kung mamimili ka na rin lang ng mas maliit sa'yo, sagadin mo na yung pinaka maliit. The smallest or the most symmetrical figure. Okay? Now, in here, itong figure na to, tong circle na to, with a chord of 10, pwedeng lumaki. Pero pwede ring lumiit. No? Halimbawa, in this figure, I can draw a smaller size figure or a smaller size circle. Ganito. The smallest circle that can contain that chord whose length is 10, the smallest is that circle having this chord as the diameter, right? Ito yun. So this is the smallest circle that can contain this chord whose length is 10. Ngayon, now the small circle inside, whose center is here also, is tangent to this. So the smallest inside circle, tangent to this chord whose length is 10, is this circle whose radius is practically 0. And the annulus between the small circle and the big circle is practically this circle whose diameter is 10 and whose radius is 5. So therefore, the area of this, if the problem is correct, And if the problem has really an answer, the area of this and the area of this must be the same. So, that is the statement of the Padilla-Shar principle. So, therefore, the area of the shaded region, which is the area of the circle, is pi times radius 5 squared. Or this is 25 pi square units. The answer will be exactly the same as this. Kuha nyo? May nagtanong sa akin dito, Sir, pwede bang gamitin yan sa lahat ng problem sa geometry? My answer is also a question. Can you use Pythagorean theorem to all problems or figures in geometry? Okay, I'll reduce the problem. Obviously, it's not. Can you use Pythagorean theorem to any triangle? No. It is applicable only to right triangle. Same thing with the Padilla-Shar principle. It is applicable only if this condition is satisfied. That you can legally change the size of the figure, meaning talagang tama yung problem. Talagang may sagot. Hindi kulang ng given. So if you can legally change the size of the figure without the answer being affected, then you may use any size of the figure because it means the reason why you can change the size is because the size doesn't matter. Whatever the size you change, for as long as no condition is being violated or will be violated, the answer remains the same. If that is the case, then use the smallest, the most symmetrical figure or the sharpest figure. So, yun yung sharp principle. Pag hindi na-satisfy yan, yung condition, you cannot use the sharp principle.